Hello and welcome back to Precalculus 1, section 110 on modeling with functions, also known as word problems. So last time, for about 10 minutes, we just mentioned what the word problems are. I did tell you that if you would like to be successful with these, you should make it personal. So if you see Jim or Allison and you don't know who Jim and Allison are, just swap those names with names you care about, right? And you go through the problem as something that it's happening to you, situation that you are trying to figure out because it's a job or a life situation, and you go through that. And we started by saying that every single piece of information you can actually translate somehow into word problem. Here is figuring out the monthly payment if you overstep data usage on your cell phone. Let's say you have to pay $50 per month flat, which is includes 4 gigabytes of data use, and then you pay $15 extra per extra gigabyte of data you use. Now the monthly cost can be put into the equation. It's a linear equation of the type y equal mx plus b, where your b, the y-intercept, is the 50 flat, and then you have plus 15 times each extra gigabyte. That will be x, so amount of extra gigabytes. If you stream YouTube a lot off of the network, obviously you're going to kill the data very, very quickly. I see some of you are shaking your heads. Yes, we are experts in that. Good, right? The companies are saying yes, right? Obviously, this does not apply if you have infinite data plan, right? But infinite data plan is going to cost more than this one here. A lot more of these, if you rent a U-Haul truck, let's say, or you rent a car, they can say you pay flat per day, and then you have certain amount of miles included, and then you are oh yes, we have the expert in the back, right? So for car rentals, right, it can be paid by a mile or paid by the day, or so there are different companies do different deals. I think Home Depot and Lowe's rent the trucks that you can I think $20 for the first hour, and then you have per hour of use. They also rent tools. If you need a chainsaw, you can go there and get it for like $40. I don't know, but let's say $40 for, right? And then you return the murder weapon to Home Depot. And it's like, I don't know what happened. I was like, this is not mine.
That's definitely not blood. I was trying to see something in the red paint was still wet.
Yeah. So the thing is that any kind of a rental would have a flat fee, and then there might be per mile, per hour of use, or so on added. All of those are this equation. Whatever the fixed cost is, it goes into this spot, and then you have additional cost per hour, day, or gigabyte used, or so on. So a lot of things can be modeled with these linear equations. Now the question is, can we make this more interesting? And this is where we take a look at the example where you are trying to pick between two, let's say, cell phone plans, where one cell phone plan is giving you a certain amount of data, or I think this is the ancient here. Yeah, they are shoveling text messages on this one. So one plan is $20 per month and a charge of 5 cents per text, and the other plan is $5 per month plus 10 cents a text, right? So let's go with text plans. Again, please understand this is an ancient example. This is not something that you would be choosing today, but you can easily transfer this into Do you want the bigger car, right, which is higher price, right, and then maybe less per mile or something like that? So there are ways to morph this into any other situation. So text plans A and B. Plan A, they say 20 per month plus 5 cents per text. That's text message. It used to be very expensive. And then the other one is $5 per month plus 10 cents per text message. And simply the question says, which plan is better? Now, this is what people usually ask, right? When they are forced to pick between two plans, you have to make a choice between two different cable companies. They have different amount of channels, different payment. Which one is better, you say, right? But is this question actually a good question to ask? Which one is better, right? And now, why am I asking that? Because clearly, we would know which one is better if I knew how many texts I'm going to send, right, in a month. So, can you tell me what my bill is if I send one text in a whole month? $5.10 for B is better because the other one is $20, and right? So the other one is almost 4 times better if you're going to send one text a month, right? So how about we model these and set them equal to each other to see where is that threshold number of texts which makes one plan better than the other plan, right? So if I model the plan A, so the cost of plan A is going to be $20 per month plus 0.05 per text. Same equation we did earlier, right, with data. For plan B, I have $5 per month plus 10 cents per text. And now we can set the cost of all of these, both of these, set the costs equal to see what is what we would call equilibrium number, right? What is the number of texts which would be, it doesn't matter which one I pick, the cost is the same, right? So 20 plus 0.05x is equal to 5 plus 0.10x. So bring 5 over, we get 15 equals to, bring 5 over to the other side, and you get 0.05x. And now x equals 15 divided by 0.05. You multiply both numbers by 100 because lazy to get the calculator. You get 15,000 divided by 5. It's 300 texts. Now let me write that in blood. If I send 300 texts per month, both plans cost the same. And that's the end of the story, right? Now, the question is, I know that I'm going to send more than 300 a month. Which plan is better? Well, clearly one is going to be better than the other because 300 is that point where they are the same. So what we discovered is that if you send one text, then the plan B is better. That means that any amount of text you send less than 300, you will be paying less with the plan B. Any number of texts more than 300, plan A is better. So see, you do not get to answer which plan is better by looking at the price. You have to make the decision also having in mind how many texts you're sending, because again, 1 to 200, well, maybe 0 to 299 texts, plan B is better. 301 to infinity, plan A is better. And this is how you make the informed decision, right? This is how you rent a car, rent a truck, rent a tool, right? All of the things that have any kind of choice. Now, why would you care about a problem, ancient problem, that has text messages, no one uses it? Yeah, you can still get and modify this problem for data, right? It's not a big deal. But there is something that is big deal. You don't think of it because, hey, you're still in school, right? So what would that be? Something that when you grow up, you start working and you have to pick. And it has choices like this.
Insurance.
Yes, health insurance plans. What do we have? We have 0 copay, $10 copay, $15 copay, $20 copay, right? They all have different charge per month. Different charge per month is this number. And then you have your copay times the number of doctor visits you make per month, right? So you will find that higher the copay, less you have to pay per month. If your copay is 0 or $10 rather than 20, then your monthly payments are higher. So now it is the same problem, except you would have 4 equations. And you do it in the matrix and you figure things out, right, but when you have to pick between, let's say, 4, some companies would have 10 different options, right? If you are picking in between 4 health insurance plans, you have to start with, am I covering myself or am I covering the whole family? If it's just myself, how often do I go to a doctor? Oh, once a month? How about we just take the highest the highest copay and the lowest monthly payment? Because, yeah, right? You go medium, then you go in, right? And if you go to doctor all the time for a chronic condition, right, twice a week, well, 0 copay makes a lot of sense because the copay would be adding to more than the difference, what is different plan, right? So, as you can see, the choices, right, in life depend on this kind of thing. And then, right, same goes with picking out your cell phone plan, picking out your rentals, picking out your there is also dentist, medication prescriptions, and a whole bunch of other stuff that once you grow up you have to do. Someone is doing that for you now. You don't have to worry about it. But it's coming up. So that's that. The next is let's set the price. Let's research the price. Let's see if we're still going to have people buy into it if we change the price. Some people argue if the Tesla was 20,000, 30,000 more, it will still be selling like crazy because it's insane value. Sure, why not, right? The prices are determined by consumers, technically. If you are willing to pay $80,000, $90,000 to buy Tesla Model S, then Tesla Model S is going to be $80,000, $90,000. Even if the production is half of it, they can make half a margin, right? If they have the best product on the market in the whole world, right? So why not charge for it? Everything that we use a lot, right? All of the people that have a lot of money, consumers are the ones that gave them that money, that made them that money, right? I don't know. Owner of Amazon, right? Bezos has his own private space program, right? Great. Why? Did he steal that money from someone? Is it that he didn't pay the workers or something? No, he pays the workers, right? Now, those are minimum wage jobs because they do not, right, use like college degree or something, right? But you have to understand that the money that he has doesn't come from stealing or robbing anyone. Everyone orders the packages there, right? You have the option to sit in a car and go to the mall and buy the same thing, right? But you don't. It's going to get shipped, right? And it's so much easier to flip the phone app and just, use your thumb going like that and then stab with a thumb, right, twice, and the thing shows up on your door rather than you making yourself presentable to public to some extent, right? Leaving the house, going and walking around to find the thing on the shelf, in a store that it's 30 minutes away from your home. So obviously, right, they're going to have insane amount of money. And then you go ahead and think of all of the other companies like Apple and Microsoft and everyone else that are making, Samsung, right? Insane amount of money because everyone has their products. And then those that you don't care about and you don't buy a lot, they fail and they're gone, right? So now, in order for us to figure out the prices and things, they do the market research. And there is a point that at a certain price range, you will just bail out and not pay for the item or a ticket or something. So someone says, I'm going to, a star or some kind of, music star or whatever, I'm going to have a concert and my tickets are going to be $40. And they say, oh yeah, $40, that's easily going to fill out 10,000, people. How about 45? Well, 45, probably 9,000. How about 50, right? And then you play the game between how many people are going to be there, right, and how much money you can make it. And then there is this sweet spot of the highest possible price that you can charge with a still reasonable amount of people buying it to create what we call maximum revenue. And that's our next problem. Market researchers on a certain route, an airline carries 6,000 passengers per month, each paying $200 for a ticket. Market survey indicates that for each dollar of increase on a ticket, the airline will lose 100 passengers. So your ticket goes from 200 to 201, and you lose 100 passengers because the threshold for those passengers was, I'm paying $200, I'm not giving them a dime more, right, to fly. And as soon as you go to 201, 100 people bail out of 6,000. Then you go to another dollar to 202, another 100 people bail, and as you keep increasing the price to 203, 204, 205, from those 6,000 minus 100, minus 100, minus 100, minus 100, because people, now you do that through surveys when they say, are you willing to pay for something, right, that goes on. So the question is, how do we model that with mathematical function? Because once I model that with the mathematical function, I can find the sweet spot of what the price should be, and by research data that we got, right, we would have that amount of people buying it, creating the maximum revenue, which leads to, if your cost is constant, which leads to maximum profit. Now, profit is extremely important for a company. Why?
Keeps them in business.
Why? That's correct. What you said, 100%.
If you're making a profit, it means that you're making more than your overall expenses. So, like.
True, but why do you need profit? Why is profit insanely important? Because you can run a business by just being flat, right? Your expenses in, expenses out. Your expenses out are salaries for all your people and yourself. So those are expenses out. So everyone is paid. All of the salaries are paid. Everyone's health insurance is paid. All of the electrical and gas and toilet paper for bathrooms, like everything is paid. Why profit? Why would you need a profit?
Upgrades.
That's the one. Profit is going to be upgrades to facility and the research and development to create a new thing so you can be concurrent on the market, so you can still compete on the market, right? Think of any new phone. There is always the next model next year, and next model next year. Slightly better, slightly better, slightly better. If you have someone who never used the brand of the phone, they couldn't tell you one from another, right? But you say, no, this is 10, that was 9, right? So ready to spend another $1,000 because 9 worked into a 10, and 10 is 11 this year, and then next year is going to be a 12, right? And it's $1,000 every time. That difference is called a profit, right? And the profit fuels research and development. So now the companies can always, this one pushes a little bit forward, this one is pushed a little bit forward, right? And they inch one on top of the other all the time. Except Intel, they just got destroyed. So I don't know. I hope they come back, but AMD just absolutely destroyed them. They have no aces left. Anyway, let's talk about this problem. So we have 6,000 people a month flying at 200 per ticket. Each $1 of price increase decreases passengers by 100. This is the information that you get when you are sitting in the airline meeting. I don't care. You're working for United, you're working for Delta, you're working for Virgin. I don't care which company you're working for. This is the info you are getting, and you are supposed to figure out, right, what is the best price for them to set up. So, let's go. If the price is 200, we will be flying 6,000 people. If the price is 201, we'll be flying 5,900. If it's 202, 5,800. 203, 5,700. 204, 5,600. 205, 5,500. And then you can keep increasing the price until you run out of passengers, right? So, how do we model this in the mathematical function? Now, they want us to use number of passengers, capital N. Number of passengers. Okay. Oh, X is the ticket price. Yeah, ticket price. Now, why is the ticket price variable? Well, because it's increasing, right? What if it's $213, right? What if it's $208, and so on? So ticket price is something that is changing. Now, we see that we are losing minus 100, minus 100, minus 100, and over here we are gaining plus 1, plus 1, plus 1, plus 1. So there is a pattern, clearly. Now, I would ask you guys to stop writing and just follow the way I'm going to create this equation. There are many similar problems, just to see how this logic works at all. Over here, I have the counter. And over here, this is decreasing by 100 each time. So, if you take any particular row, you see that you made 1, 2, 3 jumps of plus 1, and you lost exactly 3 times 100 people. So you lost this many times 100. So 1, again, you can rewind this and watch it again. It's very important now to understand that for this line, you had 1, 2, 3, and you lost 1, 2, 3 over here by 100. So this one over here is the ticket price X, and if you take away 200, you are left with what we would call a counter. And then you will multiply that by 100, and that creates the loss in passengers. So what we get is you are starting, so the number of passengers must be, we are starting with 6,000 people, and we will be losing 100 for each dollar that we increase. $6,000 people is what we would have if the price is $200. Let's check. 200 minus 200 is 0. So you are losing 0 customers if the price is 200. If the price is 201, then 201 minus 200 is 1. Do you see why I call it a counter? 201 minus 200 is 1. 202 minus 200 is 2, right? So it counts 1, 2, 3, 4. How many groups of 100 do I lose for each dollar of increase in price? So 6,000 minus the loss. And this is the total loss of customers, because for every dollar, which is discounting extra dollars, times 100 is subtracting from here. Now, these people that are, the N is the number of passengers and then you would multiply that by the ticket price to find the revenue, which is collected, right? How much money they collected from everyone. So this one over here is the number of passengers flying, and then we're going to find the revenue as the ticket price X times the N, because revenue is all of the money that they collect from tickets, and then the revenue, you have to subtract the cost for everything to run, right? This flight, which is salaries for all the flight attendants and the pilots and security and the baggage people, and then the kerosene, right? The gas for the airplane, and a whole bunch of stuff, a lot of things, huge costs, right? And then whatever is left over is called a profit, because what, in 20 years, well, you're going to need a new plane, and that's not $17, right? So you have to make profits, otherwise you would never have a new plane, and then, you know, eventually when it's so old and just falls apart in midair, right, it's done, it's over, right? So you must make profits. So they need to figure out the revenue equation, subtract the costs, and when they subtract the costs, they know how much money is left as a profit, and that goes into the account we'll need, as you said earlier, to upgrade, right, to get a new plane, and so on. Now the revenue is going to be X, and then you have your 6,000 minus 100, X minus 200, and now we need to work out this algebra to get one solid equation out of this, because there's a lot of simplification that we can do here. So revenue is going to be X times 6,000 minus 100X plus, and this is going to be 20,000 here. Revenue is going to be 26,000X minus 100X squared. And as you can see now, you have your revenue as a function of the ticket price. So this over here is revenue in terms of ticket price X. Now, as you are dealing with this equation, you want to find where is the maximum revenue. When you graph this, you have to find where the peak of this is, where the highest point of this is, because that's the point at which you have the highest revenue. This graph, when you graph it on the calculator or use Desmos or whatever, we'll use Desmos, is going to look like this. This is a 0, and you can also figure out this value here because you had the algebra. This is X, which is ticket price, And this axis over here is the revenue, and you clearly see that there is going to be a maximum point, which is maximum revenue with the cost, fixed costs, right? You are going to actually make a maximum profit. Every profitable company has people that do this analysis, which is why they're profitable. You do not eye these things because you miss marks for millions, all right? So these things are very carefully calculated. So now what we are going to do is we're going to jump in Desmos and try and figure out beautiful free math. There we go. Explore with Desmos. Perfect. And we are going to graph our equation. That was 26,000 x minus 100 x squared. What's the problem now? Oh. And you get no graph, right? Because these values are in thousands, right? You are not expecting to see the graph between 0 and 10 if the numbers are in hundreds and thousands, right? Hopefully. So you will have to zoom out. There we go. Look at that. Oh, Desmos is not.
What if you put the negative 100x squared plus 36?
Well, it's not going to do well over here. Because the number is... Okay, so can we make... How do I... Hold on, give me 1 second because I need to make my... So my x-axis, clearly we need to keep our x-axis between, let's say, 0 and 400. So x-axis between 0 and 400. That gives us the nice view of those. And then for the y-axis, I will need to put that one from, let's say, 0. Let's go with 100,000. There are ways to compute this. No? Okay, how about 1 million? Oh, we got it. 10 million? Did I type 10 million? How much they put? Okay, we can see it there. So this is 1, 2, 3, 4, 5, 6. Oh, that's 1 million right there. So do we see that there's going to be a maximum point somewhere over here, right? The way to find that maximum point is to average your x and y, your two x-intercepts. That's going to give you a middle point, and then you just compute the y value for that x. So what do we have here? Over here, this point is going through 260. So we are going to average now That's a 260 right there. So x is equal to 260 minus 0 divided by 2 is equal to 130. And now we calculate the revenue at 130, which is 26,000 times 130 minus 100 times 130 squared. So you are going to get 1 million and whatever else we got over there. So we're going to have 26,000 times 130 minus 100 times 130 squared to get $5,070,000. Now we should see that when we jump to the graph. Wait, that's not what I see. This is 130. That makes sense. But this is 1,069,000. What is going on over here? Did I type this right? 26,000 times 130. Oh, minus. Second entry. I typed plus instead of minus. See, it makes no sense because it's not the same graph. There we go. Fixed. It is $1,690,000 in revenue. So call that 1.7 million. Then minus the costs and all of those kind of things, and you can calculate, right, the others. What else can you do with this? Well, any problem that has the market research like this, go ahead, increase the Tesla car price $1,000, you would lose so many customers, right? Increase another 1,000, you lose so many customers. Also, planning an orchard, for instance, you can't overcrowd, or doing agriculture of any kind, you can't overcrowd. The closer the trees are or whatever, the less fruit they're gonna give. So can I squeeze an extra tree and lose 5% on other trees and still have the bigger return in, let's say, apples? The answer is probably yes. But again, you observe the nature, you observe the number of apples, you do the statistical analysis of all of that stuff, and then you decide whether it would be profitable to include another tree. Because, right, when you put more trees, all trees together will have less nutrients because they will be sharing the food, right? And competing for sunlight and everything else. Therefore, each tree was going to bring a little bit less in terms of apples. But because you have a whole extra tree, right, overall should be more until you reach that threshold where, what they call diminishing returns. Hopefully you ever heard about that, right? Where you have way too many trees, and then each tree is just going to bring one apple, and you can't even walk in between, right? So in that case, that's not good. Cool? Yeah, of course, math, right? Another batch of very popular problems that will definitely be there on in calculus courses are the famous farmer problems. Or farmer's problem. Whatever. Farmer's problem? Whatever. So the text goes this way. Farmer wants to fence off a rectangular area of maximum height, maximum area, but he has a certain amount of fence given in feet or yards or whatever, right? So let's go like this. Farmer has, let's say, 2,000 yard of fence. What is the max area? What is the max rectangular area because it could be a triangle, or maybe farmer is going to just put the fence in a circle and make a huge circle, right? So what is the largest, what is the maximum, largest rectangular area that can be enclosed? Well, we have a rectangle. Rectangle has length and the width. You want a length and a width, or do you want A and B? Or do you want X and Y? That's the beauty of applied. You can use any letters you want. So that's why you want X and Y, you want length and the width. Length and width? For this type of problem, right? Yeah. So this is the length and this is the width as well. Where does the perimeter fence go? It goes on the perimeter, which is where the black line is. So what is the formula for perimeter looking at the black line and the distance is given? 2 lengths plus 2 widths. Good. So that needs to be 2,000, right? Because the black line here, the outline, is where the fence goes. And now what's my area equation? Length times width. And we want that to be the max. That's area. So what do I have? From this equation, I have length plus W equals 1,000. Right? That's when we divide by 2. When you divide by 2, you get that. And the second one is L times W equals the maximum value. And now you solve this one for length or width. It doesn't matter. Let's say W equals 1,000 minus length. And then you plug in. So you get L times 1,000 minus L equals to a max. And here's your 1,000 L minus L squared equals the max. You get to graph this, and it will tell you again the L. This formula still graphs like this. And this axis here is your L axis, and there's going to be this special L max, I can call it. It's L median. But that L is going to give you the largest area, and then you can use the perimeter formula to figure out what your W is. By the way, this maximum is area. Maximum area, right? So this equation is all about the maximum in terms of L. So now you can go and graph this one. So we're just going to fix the previous problem. This is supposed to be 1000. And this is just x squared. And as you can see, the graph is not happy. We need to have x now to go from 0 to 1000. And then we'll see that at 500, right, is the middle. But let's just quickly graph this. So I will change the scale over here from x-axis to be from 0 to let's go with 1000. And we'll go with the y-axis from 0 to 1000. Why is it changing this one? There we go. And there's the graph. So now we know that there is a maximum point here, which is at 500. So we found that to get maximum area, we need length to be 500 yards. So for max area, we need L to be 500. Now when you plug that into 2L plus 2W equals to 2000 yard of fence. I gave 2000, right? Yeah. When you plug that in there, you will get that 2W is equal to 1000 and W equals 500, and we have the answer, which is square 500 by 500 yard. Yes.
So, not really, but like, if we were doing a test, since we wouldn't have obviously access to either the graphic calculator or the
You have the regular one,
scientific calculator.
or the solar one with the basic calculations. The only thing that you need to compute here is, which I'm going to show now, is how to find this middle.
Oh no, I'm just that's what I'm wondering.
Yeah,
Like,
so
if
we're
we
going to
didn't have a
use
chart, how would we-
elementary. Yeah, we're going to use elementary algebra for that. Ha.
Okay.
All right. So now, I showed two examples back to back how to use calculator to quickly come up with this, because that's where your job skill is. Now, you do not have graphing calculator on the test. How do you solve this on the exam? Well, let's go orange or blue? Green? Green. Okay, fine. On the test, solve. We had 1000L minus L squared equals to max. On the test, you will take this, factor out L, you will set it to 0, from where you get L equals 0, and L equal 1000. Min or max, depending on the problem, is at 0 plus 1000 divided by 2. So it's at the average, and then it's 500. That's the 500 I got before by looking at the graph. So you will always have the same situation. You will always be able to factor out, well, if we go to the previous example real quick, I'll come back to this. If you go to the previous example over here, look what you have. So to do the green calculation, I'm going to factor out 100x, and that leaves me with 260 minus x equals 0. 100x equals 0, x equals 0, and 260 minus x equals 0, x equals 260. When I average 0 plus 260 over 2, I get 130, which is the number that we were tossing around to calculate the highest value. So it's always going to be the average between these two, and these guys are intercepts, so you can always average them, and then you will calculate your revenue, or you will calculate your area at that value. Yes.
So because it's like a square, that's why you would divide it by 2, correct? Or always you would divide it by 2?
No, you're dividing by 2 because it's a parabola like this,
Okay.
so the maximum is always halfway in between. So that's the maximum is happening right here, which is this point here, and this point is that 130.
What if it wasn't a parabola?
It is always going to be a parabola.
Parabola, okay.
It's always going to be a parabola.
That answers that.
That saves the day, right?
Yes, because I was going to be like, well, then what? It's like that weird squiggly thing.
Then it's calculus 1, because we do all of these problems with scarier functions in calc 1, but then you have the derivative, you set the derivative equal to 0, you don't have to worry about any of this averaging or chasing graphs or anything.
So I'm the 2% thinking.
With your question, yes, you are, but that's great, because you are exercising the best practice in learning. What if, right? Because one thing is just to regurgitate information and being able to vomit it back on a test. The true knowledge happens when you say what if. So yeah, but your answer is going to be in calc 1, and I'll see you there.
After the break.
No, there's pre-calc 2 in between, and then.
Yeah, I know.
Yeah. Not for all majors, right? But some of you will be taking calc 1. You will do same problems from scratch with this stuff over here being introduction, and then over here you take what we call the derivative. So that will be a calculus way, and you will be literally skipping all of this, plus looking at the graph and everything else. But that's done. What we are going to do is we are going to now say that this farmer plot of land is adjacent to a river. And we're going to redo the same problem because it worked out to be a square, right? Is answer always the square, so we don't have to worry about? No, right? Depends on configuration. So if you have a river, if you want me, I can put some salmon in it or something. So here's your river. I'll toss in salmon, so this way you know it's a river. A student said, those are carrots. No, they're not. Carrots have the green tops. All right? So, yeah. So that will be salmon right here. All right, cool. So we have salmon, right? And now our fence, it's going to go like this. We still have the length, we still have the width. Or whichever way you want to put the width there, I don't care. So how does this change our life, right? Well, the black line, which is the perimeter, which is where the fence goes, if you look from the bird's perspective, right, is not going to have two L's anymore. It's now going to have one L, right? So it's going to be L plus 2W equals 2,000 yard of fence. And you still have your L times W to be max for the, right? And now the steps are always the same. Take the equation without the max or the min in it. Solve it for a variable. Pick which variable you want to solve for. And then plug that into the other one. So now we have 2,000 minus 2W, everything times W, equals to max. And here is your 2,000W minus 2W squared equals a max. Now I'm not even going to try using the graph. I'm just going to go straight through calculation the way you would do it on the test. I'm going to factor out what? 2W. What's left? 1,000 minus W. Beautiful. We set it equal to 0. 2W is 0. And 1,000 minus W is 0. So here's W is 0. And W is 1,000. And what's the average? Average W is 500. You said, wait, that was what we had before. Yes, we had W equals 500 before, but the length this time is not going to be 500, right? Because we do have an equation for length. So when you drop the length and a W together here, the length is 2,000 minus 2W. The length is 2,000 minus 1,000, which is 1,000 yard. So the new dimensions are 1,000 by 500 yard. So it's no longer a square, right? Now it's a rectangle. It's always the same problem. Just the question is the geometry of it, the equations you start with. You either have the perimeter with all four sides. You can toss in more sides, right? My favorite jokester problem for the modified farmer problem is you add these fence in the middle. So you can put different things in 3 different bins. So I say cabbage, rabbits, and tigers. You don't mix these things. Do you know what will happen with rabbits if you put them in the same bin with tigers? Right? You won't even find the fur.
It's like that problem where you send like the cat, the rabbit, and the fox across the river and back.
Yeah, well, this is just separating, right? But now, and you don't want to put the rabbits with the cabbage either, because the cabbage will be just done in a day, right? So they have to be separated. And now you have the fence in between. And because you have the fence in between, you still have your length over here and over here, right? But what happens with widths? You have 4 of them, right? Because this is going to take the fence, right? So now you're going to have a W, 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 W. Your perimeter equation is 4 W's plus 2 lengths is 2,000. And your area is still length times W, and you want that to be max so you can have the largest possible bins for animals. Not going to be square again. Not going to be square. Calculation is still the same. Solve for, let's say, L. Solve for L. Plug in the other equation. And then, let's do it one more time because we can. And we're going to do something else. So take it from here and say 4W plus 2L. So that's going to be 2W plus L equals 1,000 when you divide by 2. And then L is equal to 1,000 minus 2W. And you plug that into A. We get 1,000 minus 2W. Everything times W equals a max. That's 1,000 W minus 2W squared equals a max. And now you do the green procedure, right? Factor out what? Very good. What's left? Perfect. Your 2W equals 0 is W equal 0. And 500 minus W equals 0 is W equal 500. We all good? The average over here is clearly what? 250. Perfect. And you know that each one of these is 250 now. And you can calculate your length because you have this equation here. So pulling from that equation and pulling the average W, the L is equal to 1,000 minus 2 times 250. It's going to be 500. So now it's way smaller, right? It's only 250 by 500. But you used a lot of fence for those divisions in between. Right? The goal is not to go and buy more fence. Right? You have 2,000 yards of fence on the pile. Just use all of it up and fence off the maximum area. So now it's going to be 500 by 250 yard and so on. You can literally bring any geometry as long as you are able to calculate. As a challenge to my Calc 1 students, which you should be able to do as well, right? You can make weird, so I give them the good old, like that, right? So let the rabbits, right, live in the small compartment and put a lot of cabbage around, right? You don't want them in the same. Or put the tigers around and put the rabbits in a small one, right? All of the rabbits would be right here at all times. So this is still a length and a width and the width, but this one is, let's say, width over 2 and the length over 2. So now those two would be added, right, as a plus. So you have 2L plus 2W plus L over 2 plus W over 2 equals 2,000. Area is still length times W equal. And you plow through the fractions now, and you still come up with the answer at the end. So I'll just say fun. And this is not going to be on the test like this, but you could have a combination between the bins and a river, just the bins, or you can have airplane ticket, but instead of airplane, ask it as an orchard, right? So the more trees, the less apples, which is the same as higher the price, less passengers, right? So all of those work together. Now we have 20 minutes left, and we have, I think, 3 problems that we should talk about, but we could make it less. If you ever visited my office, you would see that I have a couple of these boxes on the shelf that are made out of paper, right? And those that were of the interesting design and calculated correctly, I kept, right? One of my favorites is the companion cube. If you ever played Portal, you know what it is. So one student decorated it as a companion cube. These problems, again, do the same thing. We would like to find the maximum volume of the box, right? Now, something like this you can't compute because it's not going to be a parabola, so we don't deal with this problem. You would be able to find it on a calculator if you are to, graph this carefully, but you will not be asked to do that, so you don't have to worry about getting the numbers. But one thing that you are responsible for is the title of the lecture, which is figure out the volume of the thing. So if I want to create a box or a tray that has no top, a drawer, perfect, yes, beautiful. It could be a drawer. So I want to create, now I actually asked my students to make this out of paper, and go ahead, make it. Put the paper into a square base by taking just a regular printing paper, and the way to get a square out of it, because it's a rectangle, fold this edge over, it will fold, creating the square, and you just cut this piece off. And when you unfold it, it will be a perfect square right there. So what we have here is a box that has dimensions. Oh, they actually have different dimensions. I can't. No, I'm not going to label it like that. So now you know how to get a square paper. So where is it said? A machine produces an open box using a square sheet of metal measuring 12 inches on each side. So what you do is you feed into the machine a square metal like that. The first thing that happens to it is the machine punches these edges out. And then takes it where those edges get bent. So now you have this square base and these edges are bent upward. Right? And then eventually it looks like a tray or a drawer or whatever you want. Do we all understand the concept of this? Now, when you bend those edges up, you just put a piece of tape, right here. Put a piece of tape, and it's going to hold it. So one of the projects in my Calculus 1 class, questions that it's on and off, right, is to actually do the calculation and make the box. Now, what we have in the calculation here is they say that this was 12 by 12 square. Now, clearly, when you do, if you're interested in doing the project at home, right, it's going to be, what was that, 8.5, right? 8.5 by 11. So you're going to have 8.5 by 8.5. Or cut it down to 8 by 8. I don't care. Just get a square of some kind if you want to try this. And now we have a 12 by 12. So question is, how much do I have to punch out? And that's the unknown x. How much do I have to punch out for these x by x squares in each of the corners in order for me to create the largest possible volume to fit in, right? So the way this is done is you make a mathematical model where you understand that from here to here is 12. And from here to here is x. From here to here is x. And how much is in the middle?
Would that be half of 6?
Well, we did not say we cut it half, right? So if the whole thing is 12 and these small pieces are x each, which we don't know how much they are, but that's how much we're cutting off, how much is left in the middle over here?
12 minus 2x.
Beautiful. 12 minus 2x. 12 minus 2x, because look, this x plus x is 2x. Minus 2x, they cancel, and you're left with 12. So when you punch out these, now we know that the box over here is 12 minus 2x by 12 minus 2x, and that each of the heights is x. So when you want to write the formula for volume of the box, so I'll draw another one. This one is 12 minus x sorry, 12 minus 2x by 12 minus 2x by x. So volume is 12 minus 2x squared times x. That's the volume. In terms of how much you punch out. Now, to find how much you punch out, you would have to use calculus, you would have to use graphing and so on, because it's now not a parabola. Now it's x cubed, right? Now, they do show you how to find that in the book on the graph. But there is really no reason to break your heads over this, because you will be calculating these things in a single step like that in Calculus 1. So as long as you give me the math model, I am very happy camper, because that is going to just upgrade the extra calculus step on it. It's going to be the same problem. Let me see if I can I pull it up? Calculus 1. Where's my optimization? 4 point, there we go. And what are we seeing here? Airport box. Oh, that's the difficult problem. I'm gonna do this one now. Oh, look, it's a farmer. Except, oh, and with a salmon, see? And this is the same calculation, except we have that red dy, dy, that's the derivative. So they don't mess with graphs. Same problems, and the problem we just did here, they have to do as a project problem and bring in the physical box to class as the part of the project as well. So if you're interested, go ahead, pick a size of a paper, right? Make it square. You can do 8 by 8, but 8.5 by 8.5. Do the calculation by hand, cut it out exactly, and you will have it. So a lot of these problems, and I want to do the box, or we can do the, oh, there it is, a problem 64. A pool measuring 20 meters by 10 meters is surrounded by a path of uniform width. Now that path is the concrete, around the pool, so the kids can run and scrape their knees. It's the only reason why we have it. Memories, anyone? Yeah, I see. Okay, good. Don't run by the pool. Runs by the pool, scrapes knees. Wah. Yeah, good. So here is the pool, and the pool is 10 by 20. They did meters, so this is 5 times my height right here, and this is 10 times my height over here. And the path around, so that's the concrete. And they say, express the area if all of these are equally distant. Right, so if that's x, that's x, that's x, and that's x. There we go. So now, who can tell me what is the length of this side here, looking at the measurements?
20 plus 2x.
Beautiful. 20 plus 2x. Because I have 20 for the inner, and then you have x on each side. How about on the vertical? All I heard is What was that? 10 plus 2x. So the area must be length times width, which is 20 plus 2x times 10 plus 2x. And if you want to FOIL this, you get 200 plus, that's 2060x, right? Plus 4x squared. And that's area in respect to how much, right? How much width do you want for the concrete layer to be? And obviously, more area, more concrete, more cost, right? To pour the concrete and have the workers stay longer and make everything flat, and right. So obviously, more x you bring, the higher area, and you see that x is just adding right into the hole. Now, do we also see the flat 200 area of the pool? 10 times 20 is 200. That's the fixed. Your x cannot affect that. If you put no border, that's going to be x is 0, right? There is no width. X is 0 meters, then kills this term, and the only thing that is left is the pool. 200 by 200, right? So you have your grass, and it starts to water. There is nothing, right? Nothing there. So as soon as you start making this path like 2 meters wide, which is my height, right, to make maybe more 3 meters wide, then times 3, well, times 3 times 3, you subtract the 200, it's the amount of concrete, right? Now, do you want your concrete to be 6 inches, 8 inches, 10 inches, right? Then, right, that's going to be the volume of how much concrete is purchased, right, for the build. And, you know, if you know these kind of calculations, then, hey, no one gets to give you a quote they like. You get the real quote, right? Because you can check the calculations. I'm just going to mention that, is this the only problem if we have a pool? No. In the calculus, they say a rectangular flower garden and you want to have a piece of grass around it. That's fine, right? You can do that. It's very useful for Minecraft. Books, designing books, right? If you take a look at the page, what you have is the margins around where there is no text. In the middle is your pool, right? So if you know how much, now why would that be? These textbooks are insanely expensive because it's very expensive to make them and ship them and do all of these things. These prints, the paper, the hardcover, the binding, right? Offsetting and you know, designing and putting in all the steps, obviously writing their royalty there. But there is a lot cost goes into trying to figure out, you know, the ratio between the margins and the text and so on. Books used to have a lot of margin on the side because people used to write notes directly into the book next to it. Now people don't even read the book, so it's like you buy it, it's $200 dust collector, and then you sell it for $30 back, and right, no one reads it. But if you read each page over here, there is 1,300 pages. How much is the book? 200 what? 260? 260 divided by 1,300. Oh, it's 20 cents per page. Dirt cheap. 20 cents per page. So each lecture is $1, most 5 pages, right? So that's the cost. But if you read all, obviously, if you just open it on, you know, every 10th page, then obviously the cost goes up, right, per page if you don't read it. So read everything, right? And then there's also that agreement thing that they put in. That's good. If you can't fall asleep, you read that. Pass out instantly. Cool. Bye. I'll see you Wednesday. We're downstairs, right?
Yeah.
Perfect.